All right, ladies and gentlemen, I'm excited for this video. It's one of my favorite theorems to use when we're talking about quadrilaterals, and that is the trapezoid mid-segment theorem. So the goal of this video will be to show and define what the mid-segment theorem is and use it in some algebraic connections and application as well too. And so what is a mid-segment of a trapezoid first and foremost? Remember the mid-segment of a triangle. The mid-segment is simply a segment that has two endpoints that are midpoints. And so here, M is a midpoint, N is a midpoint. How do I know that? I know that because N is halfway between B and C based on these two congruency tick marks here, and likewise for M. So that makes MN a midsegment. Well, what's true about the midsegment? The midsegment has a handful of characteristics. Specifically, MN, the midsegment, is parallel to both of the bases. If you remember correctly, we actually had a transitive property of parallel lines. So if AB is parallel to DC by the definition of a trapezoid, all right, and MN is parallel to one of them, well, that means that by the transitive property of parallel lines, it must be also parallel to both of them. So that is one characteristic of our midsegment. The other characteristic is that the midsegment is equal to 1/2 of the sum of the two bases. And so it is equal to 1/2 of AB plus CD. Now just be careful, not the two legs, the two bases. So how can we put this in some application? Well, what do we see here? I see that the diagram MN is a midsegment. And for this midsegment, it is going to be half of the sum of the two bases. So I know for sure that MN is going to equal 1/2 of 12 plus 28. Again, how do I know that? Because of the trapezoid midsegment theorem. So PQ is 12, SR is 28. We substitute them right in. And then we take 12 and 28 and we get 40. And 40 divided by 2 is 20. And so the value of our midsegment is in fact 20. And we can use that in a variety of different ways, of course.